two variables, maybe y and x. So you'll have, for example, a process where you find that process is defined by these two variables, and then at the end of the day, you need to determine how maybe each of these variables affect the process, but also how they are related with each other. So correlation helps us to measure the strength and direction of the relationship between these two variables. It quantifies how changes in one variable are associated with the changes in another one. So for example, if we affect x, how does it affect y? So studying correlation helps us to understand that, so that even when we are doing, for example, modeling, you will find you have a number of parameters, and therefore you are required to correct in big chunks of data. But sometimes you find some parameters are not so impactful on the process. So this correlation helps you to isolate those other parameters that may not be so impactful on the process, and therefore remain with those that carry a lot of meaningful. And if any any variation in any of the remaining parameters would obviously result into a significant change in the whole process. So types of correlation, we have a positive correlation and we have negative correlation. The positive correlation is when one variable increases and the other variable tends to increase as well. But in a negative correlation, when one variable increases, the other one tends to decrease. Then you also have another type of correlation where there is no correlation. So this tells you that there is no apparent relationship between two variables. An example can be the shoe size and intelligence. Someone can have a big shoe size, but he can be more intelligent, he may be less intelligent. But you cannot establish the relationship between the size of the shoe and this intelligence. But you can establish a relationship between the shoe size and the age. Yes, because you can say maybe or the shoe size and weight of the body. Because the bigger the bigger or the larger the weight of the body, then maybe you probably could have a bigger shoe size. So there is some correlation. But shoe size and intelligence, no correlation. And then we shall also look at correlation coefficient. Correlation coefficient represented by R. So that correlation coefficient varies from -1 or ranges from -1 to 1. So when it is 1, there is perfect positive correlation. When it is -1, there is perfect negative correlation. And when it is 0, there is no correlation. So these are important to note. So we will also find that sometimes it may not be 1, it may not be -1. It can be maybe 0 or so close to 0, and then therefore can take it to be 0. But some other times it may be lying between some other ranges, but obviously always either less than 1 or above. Okay, it is never above 1, so it can be either less than 1 or -1. So when it is 0.7 to 1 or -0.7 to 1, then we are saying there is a strong relationship between the variables. If it is 1, of course, we said there is a perfect relationship. If it ranges from 0.3 to 0.7, then there is a moderate relationship. Then 0 to 0.3 or 0 to -0.3, then there is a weak relationship. If it is 0, then there is no relationship. There is no, of course, if there is no correlation, then the relationship strength is 0. The use of this correlation, the correlation is used for identifying relationship between variables to understand the degree to which variables move together. Limitations, correlation is not the same as causation. In other words, a high correlation does not imply that one variable causes the other to change. Yes, you have to understand this. Then a linear relationship. Correlation measures linear relationships. It may not capture non-linear relationships well. So you can always utilize this to analyze any linear relationship process or any linear process defined by a linear process or a linear model. But where the process is non-linear and therefore with a non-linear model, in other words, where if the variable is like x and y, and you see something like x squared, you see x times y, all those are non-linear and therefore are not they are not suitable. I mean, you'll find that correlation is not suitable to analyze that kind of relationship. You'll go to other models, kind of. You'll have to apply other models in order to analyze the relationship between the two. Then regression analyzes the relationship between a dependent variable, also known as responsive variable, and another one, which is called an independent variable or a predictor variable. It is used to predict the value of a dependent variable based on the values of independent variables. Like we had earlier on said, if we have y that it depends on x, okay, maybe it is x plus a constant. This is a linear model. So if this is a linear model, we can use regression. We can use regression, obviously, to determine maybe the value of this y when we vary x. Maybe k is a constant. So regression is telling you how you can estimate the relationship between a dependent variable and an independent variable.